WAWTTAR is an interesting thing. I'm terrible at doing these kinds of names, but when we first did this program, this idea, I remember Bob and the other people working on it thought a long time about coming up with a name, and they finally came up with we pronounce it WAWTTAR, which was for water and wastewater technologies appropriate for reuse. And we developed the program and materials that went with it as part of the Middle East peace negotiations in the early 90s. And we made a presentation, week-long workshop to participants from the Middle East, from the warring countries. And we weren't really, there was a lot of controversy about getting the thing together. Anyway, first day of the conference workshop, we talked about WAWTTAR, and there was a lot of interesting looks on their faces at the name. And fortunately, we worried, oh my gosh, maybe the main name means something in Arabic that was not very nice. And it turns out it meant something related to water. It was like beautiful water or something. So we really lucked out. It could have been bad. Anyway, what I wanted to do is just go briefly through this. I think that the time that is set aside in the program for questions and answers is probably better spent than this time, so I don't want to spend too long on this, but a little bit of background of what this particular tool does and its philosophical bent to wastewater facility planning, and then a couple of just very brief demonstrations of the results from it, and then we can go back to answering questions. So at the top half of this slide, conventional wastewater facility planning is dividing the thing in half. You take the facility planning for the wastewater and you view the discharge, the treated wastewater, as a liability. It's like, what are we going to do with this stuff? And we have to view it that way because the guy with the penalties is going to come and hit you with a stick if you don't satisfy the discharge requirements. Well, then sort of the other half of it is, oh, well, gosh, we have some water. Why don't we put it to use? And then we worry about how to use it, and there's an ultimate disposal. So the two parts get separated. The wastewater planning part is separated from the reuse part of it. What we wanted to do in WAWTTAR is to view that in one package deal, where you don't try to look at the reclamation facility, the wastewater treatment facility, independent of the eventual reuse. And the reality is wastewater gets reused. Every drop of water in one way or another is going to get reused. There's only so much on the planet. Even if you discharge it to the ocean, eventually it's getting reused in some fashion. We're recycling the material, so we might as well plan from the beginning for the ultimate reuse, the inevitable reuse, and then we take this asset from the beginning. As Bob said, it's the most reliable. What comes in goes out. If you're drinking water, you got a water supply. Okay, so it may not be the most pleasant thing for most people to contemplate, but the reality is you either dump it in your waste in the Mississippi, run downstream 5 miles, pull it back out as drinking water for the next community. You might as well just put it back in your water supply in the first place. At least it's your water. You know where it came from. Okay, so the objective for WAWTTAR was to provide some tool that would be useful to focus attention on the inherent value of treated wastewater effluent, recognize that inevitably the wastewater is going to get reused, and then try to help pick treatment technologies that were appropriate for the target community. So many times wastewater treatment facilities get built for the wrong reasons. They are cheap to build, but unfortunately expensive to operate. Or the design engineer was familiar with one technology, that's really great. Unfortunately, it doesn't work very good in this community. And there's so many failed plans that you end up with systems that are certainly not sustainable. We wanted to provide a way for information to be exchanged between people for successful projects. So have some kind of database where we could put in what the treatment technologies look like, how they work, what their good things were, how expensive they were, what's the performance, and how do they fit into a community setting, what resources are required to make them work. I talked earlier about wishing we had information on permits and costs for facilities in California. You know, WAWTTAR was an attempt to provide a vehicle that we could dump that kind of data into so it could be easily shared with other people. The database of technologies and their costs are split into a bunch of different components. First, there's components in there for collection systems, for treatment standards, discharge standards. We'll call treatment trains the parts that make up the treatment of the wastewater, and then treatment and reuse processes. So those are the parts. We have some existing stuff already in there. There's about 120 different wastewater treatment processes, for example. There's a number of different discharge standards, several different collection systems. And for each of those, there'll be information provided already. And then the part that the user is supposed to provide when we put this implement into a new community is the user would put in a description of their community. Just briefly what each of these components contain. The collection system component primarily contains information about what it costs to build that collection system. The discharge standards component would say for any particular discharge standard, what were the water quality constituent limits, either min or max values. Treatment trains are just collection of treatment processes arranged in a particular order. So how the different things would be put together. If we look at treatment and reuse processes themselves, those are broken down into a number of information in a number of different areas. We have construction and operation and maintenance resource requirements. If you need diesel fuel, is diesel fuel available in this community? If you need a certain type of trained personnel, is that available? So this helps to identify treatment processes that would not be appropriate for some community due to a resource limitation. There's information on construction and O&M costs. There's information on the performance requirements, both what quality of water has to come into the process and what quality water will leave the process. You can't treat certain types of waste with certain types of treatment systems. So that information is contained within the information available in WAWTTAR. There's information on how adaptable this system is to changes in influent conditions, how adaptable it is as they say the community grows, how easy it is to expand the system over time. Then there's information on social, economic, and environmental impacts, and a lot of reference material. So it can serve as a poor man's Wikipedia. So that's information that we provide up front, or engineers, planners could continue to add to over time. A community, when we apply this in a particular community, the community then has to describe their problem, and they have to describe something about their demographics, something about the economic setting, so details about the particular project, planning project. They have to provide information that helps us to localize construction costs. Costs can be easily, they're based, the construction costs within the program are based upon 1992 U.S. Construction Cost Index. Those can be translated to current costs by inflation rates, but then also there are regional differences. We've done a lot of work, for example, in Hawaii. Regional differences there is about everything is double. So you got to account for that. We've used the program in a lot of places other than the United States. And again, there are regional differences in costs there. For example, I'm going to show some results for in Mexico, where the labor cost is about a quarter. We've used a lot of the work in parts of the United States where, for whatever reason, there are local differences in some of the materials or construction costs. Those can be reflected within WAWTTAR. So your community's costs that you come up with reflect local conditions. There's also information that you'd put in about the site characteristics, meteorological characteristics, precip, evap, And then resource availability. This is a lot less important in the United States, but if this is going to be applied in places where there's either human or material resource availability constraints, this helps to prevent selecting treatment alternatives that are not appropriate. There's also information that you put in about social or cultural characteristics or considerations for the community. Again, not particularly important in the United States, but as it turns out, even there are some situations where there are regional differences, regional preferences for certain considerations with regard to wastewater treatment that you could put in. For example, when we first started working in a very small community, a rural community in Hawaii, we would talk about reuse, and one of the things that became very clear is that in their society, these are mostly Native Hawaiians or Samoans, Tongans, that this odor was just, they could not deal at all with any possibility of any smell whatsoever from the waste treatment plant. Now, we're all a little adverse to odors, but this is totally different than that. This is, magnified by 1,000,000 times. So in their community, it was absolutely imperative that any possible odor from wastewater not get to the residential areas. So it makes a difference. It changes what technologies you might want to have. They also have a natural aversion to reuse. Solids reuse in particular. The liquid reuse is not so much of a problem, but the solids reuse is like, we don't do that in our culture. Now that's, okay, well, so we better think a little more carefully about what certain treatment systems we might want to put in place. WAWTTAR's job is to run through this series of sieves to try to come up with feasible waste treatment trains, collections of processes. So you start off and take all possible treatment trains, and then you start chopping them down. So there are going to be resource limitations which might come into place. You don't have a particular resource, whether it be human, material resource, energy resource. So some possible processes are not going to be feasible. Then there might be social and cultural considerations that further screen out certain. There's limitations on processes. Because of the nature of your wastewater, you can't, this treatment process won't work under those situations, so they fall out. Then in some cases, there are reuse quality limits. You have a particular reuse in mind, you need to have a particular water quality available for that, so that gets cut off. And then almost all reuses have an ultimate disposal, and there's some effluent limits associated with that, so that might further cut down on the number of possible trains. When you get done, you're left with what we call the feasible waste treatment trains. Then what you want to do is prioritize those based upon costs or whatever factors are important in your community. In terms of the selection, how do we choose the selection consideration? We want to select among the feasible trains that have some desirable characteristics, but we want to also look at the trade-offs between selecting them. There are quantitative trade-offs, like the capital costs, O&M costs, useful life, what is the salvage value, land requirements. In some cases, there might be a great treatment train, but it has land requirements that you can't meet. Either you can't buy the land or it just simply isn't available. There are also qualitative considerations that allow us to select between feasible treatment trains. In those cases, it might be operational ease, reliability, how easy will it be to expand, the adaptability to reuse, the aesthetic issues. All of those are factors that a community needs to put into this. And again, the whole reason for all of this is it's not going to be sustainable if the community can't afford it, the community's not interested in it, the community won't buy into it, and really make it part of their community. WAWTTAR provides as output a list of all the infeasible trains and why they're infeasible. That's a useful educational thing to look at. It also tells you what the feasible trains are, and it ranks them by either capital cost or total cost. You get to pick. And then it gives for each of the feasible trains some additional information. And you can look through that and sort of decide, oh, well, I don't necessarily want to look at the least cost solution. There might be other factors. The program was designed primarily for engineers and in some cases planners, but they got to have some wastewater treatment training. And it's also been used primarily to do wastewater facility planning. At least in the US, I mean, that's the primary use of it. Another reason we designed it was to allow government or NGO planners to look at donors. You know, if somebody says, you know, I'm going to give you this goodie. I'm going to give you an activated sludge plant. And isn't it nice? It's $2 million worth of stuff. I'll drop it right down in this community. Well, in many cases, that's a kiss of death because the community that's going to receive the prize can't keep it going. They plug it in. A week later, the motor burns out. There's no more motors in their country for that, so it's kind of a waste. If you travel overseas a lot and you go on the back roads, you see everywhere the remains of gifts, pumps, treatment plants. My first trip to Chile, we were out in we went through about 5 or 6 different communities, and I kept seeing these giant trickling filters, just rock basins, basically, all of them abandoned. And I asked the guy who was driving us around, he says, oh yeah, there was a period of time there was a big donation from a US company to put in all these trickling filter plants, and they all broke within the first year of operation. And then they just, that was it. So the containers are still there, they're still filled with rock and nothing, they're not working at all. Okay, and the other design use for the program was for technical students, engineers, planners, where WAWTTAR can serve as a resource base just for information. Where we've applied it, this is just some of the places. These are both rural settings. In Jamaica, in Bulgaria was more of an industrial, municipal setting. West Bank and Gaza, we had peri-urban there. Palau, and then a couple of rural Hawaiian communities, and Willits, Garberville. I mean, other places too, but these are just examples. And if you had any interest in learning more about this, that's the website where the program can be downloaded, and the manuals available, that sort of thing. So that's a little background on the program. Now let me just show you a couple of things, what it looks like. I want to look at, start off with, just pick on Garberville. Bob and I are working with Garberville right now looking at upgrading their facility. They currently have a couple of oxidation ponds, and they're meeting, but just barely, their waste discharge standard. They have to look at expanding the facility. It's a little smaller than it needs to be, and then upgrading the quality of the effluent. And one of the things, just to tell you how long it took me, I took about 15 minutes to put in the data for Garberville. So this is not an insurmountable task to put this together. It just takes a few minutes to get the data in. And I want to look at 2 different scenarios because they illustrate so many times why communities end up with poor choices, non-sustainable from an economic perspective in their community, where the decision is to look at a relatively short planning horizon. A very common community planning horizon for a waste treatment plant is 20 to 25 years. That's very common. And you do your financing on that, and so you go out and you spend your money, and then 20 to 25 years later, most of these systems have very little salvage value. So you just almost start over again. Now, one of the problems that comes up is that many of the technologies that are, I guess I'll call them more natural, the ones that Bob was talking about earlier, they involve the purchase of land. They're a little more land intensive. Well, the land doesn't disappear in 20 years. It has an infinite salvage lifespan, or a very, very long one. Arcata is using a treatment plant that was first purchased in the 20s, the land, the 20s and 30s. And the same footprint has been used over and over again by just sort of expanding, enhancing the quality of the treatment, but on the same footprint. Now, they could have, that long ago, built, at that time, a conventional treatment system, and every 20 years had to make the footprint bigger because they'd have this mechanical system that requires more space. Well, unfortunately, and many times, if you take too short of a view of the design life of your facility, you're going to shortchange yourself, and you might pick a treatment technology that looks attractive in the short run, but really is not going to serve the community into the future. And this is an example of this. Let's look at, if we take the 20-year life here, and let me just put, I think I had a Garberville standard here I'm just going to pick this one just for, that's not, I thought I had one in here already, but just run this. And I want to display, let me do one other thing. I want to just look at the Garberville. I got two different, just illustrated treatment trains that we'll look at for Garberville. One of them is a pretty conventional waste treatment system. Okay, so this is the kind of this is the text kind of output. So let's look at these two treatment trains. The first one there at the top is a pond and a wetland. So it starts off with a very simple screening bar rack, followed by a pond, followed by a wetland. This is the system that's been proposed for Garberville, hopefully going to construction starting either later this year or early next year. And there's a relatively high cost associated with the land. You see in the far right column, we're talking about $1.2 million for the buying property for the pond, about $500,000 for the wetland, and you can see the capital construction costs there. So the total for this whole system, we got a total of about 3.5 hectares, so about 10 acres. And the land cost there is $1.7 million. So this is not an inexpensive facility to put together from a capital perspective if they're going to buy the land right now. And it otherwise meets the effluent quality considerations we have. As an alternative would be to look at more of a conventional system. This is in this case, we have a screen followed by a grit chamber, an SPR, which is just an activated sludge system, and then we have to have some way to deal with the solids, so sludge lagoon, sludge landfill. Also, it's a very common system for both large and small communities. It does the job just fine. Now, if we look at this summary of the costs here, and just compare the capital costs, this is total project costs over the life of the project, the 20 years. The capital costs, notice that the pond actually costs more to build, almost double to build. The O&M costs tell a different story. Over 20 years, the O&M costs are significantly less. Now, depending upon whose interests are being held here, the capital cost people, the construction grants people would love the lower capital cost project. Maybe even the consultant might, because after all, the consultant wants to see this project built. Somebody who's got a very short window view on the problem might be very interested in minimum capital costs. This is particularly a problem when the capital costs were picked up by somebody and you sort of wanted to drag that down. Unfortunately, the community then stuck with a relatively high operational cost. But even so, just independent of those differences, look at the total project cost. They're almost the same. 4.4 million versus 4.9 million. About the same total cost over 20 years. Okay, now what I want to do is look at what happens. Let's do the same thing And this time I want to pick as the community. Oops. There's just only difference between these two is we're going to go to a 40-year design now, where I'm interested in my cost spread out over 40 years. I'm going to run this system. Now let's look at that same table. Look what happens. The problem is here for the SBR system, which had a lower capital cost before, now it's way higher because I got to build 2 of them. They don't last for 40 years. The pond system just perks along. Yeah, after 40 years, you might have to go out and do a little minor maintenance, but in comparison, when's the last time Arcata, Dobie, you still here? When's the last time Arcata did sludge removal in the oxidation pond? If you have to do it, that's after a very long period of time. Yeah, and it's not like you never, but it's not something that you worry about every 20 years, that's for sure. So here, looking at this longer perspective, now the choice is very clear. What would be the better choice for this community? Now, this is in a situation where the land is available. I've done everything I could possibly do to make the SBR system attractive. In Garberfield's case, they actually have the land. I put the cost in anyway, but the land's already bought. They own it already. So in that system, it's actually even more attractive. So now the hurdle is just getting it permitted. And people said, well, we know these systems work. Why is that a problem? That's a good question. Okay, so that's an example of one thing that you can quickly do with WAWTTAR. Now, are the costs perfect? No. Are they in the ballpark? Yeah. Does it take a lot of work to get this up where you can get some reasonable estimates? No, it doesn't take a lot of work. So that's just one example of the way we can use this to illustrate. It's just a calculator. It's no big magic. Okay, now as just one other example, quick example, I'm going to look at one, I don't know, we spent even fiddling around to get the community in, 10 minutes? Probably, yeah. For the system that Bob was showing earlier at the university down in Mexico, we got results within 10 minutes, and we did have to make one minor adjustment not to the community's information, but just some cost. It turned out that we were hard pressed to find solids disposal. They were too expensive, I guess. That's the one thing I'd say. So we really hadn't thought in our database of treatment processes how inexpensive, for example, a sludge drying bed could be put up. In the U.S., he's probably got to, it's a lot more expensive to do that sort of thing here. But within just a few minutes, we came up with costs within about 10% of what they've costed out to build a facility in Mexico. And that is local costs. We try to put in, for example, in this community, just so you can see how we localize costs. If we go to the community and walk and financial, we have these things that allow us to adjust costs that relate to U.S. costs versus cost in the local community, or normal average U.S. cost versus cost in the community. So structures, 25%, labor about a quarter, concrete about 75%. Once those numbers are put in, and it takes a little bit of knowledge, local knowledge, to be able to do that, but once that's in, then you're getting costs that are regionalized for your community, whether it be in the U.S. or anywhere else. And this whole thing, we spent 10 or 15 minutes to do this. Now, over and over again, one of the very first times we used WAWTTAR for a U.S. project, we were sitting in with, I don't know, it was $1 million meeting with the largest consulting firm in the United States, one of the largest. And they had spent about $50,000 to do a cost estimate on a treatment plant, and they proudly told us that the cost was, I think it was like $1.2 million, plus or minus 40%. So I typed in, while they were talking, I just typed the same stuff into WAWTTAR, just the general size, and we had basically the same cost in 5 minutes. Okay, and I didn't have plus or minus 40%. I don't know what the plus or minus was, but I didn't need $50,000 to do that. So here's a case where if projects, similar projects in similar communities, if the cost data is available and you knew about it, and it's not just costs, performance, regulatory constraints, all of those things, it's really important for us to be able to share information and learn from each other. And you don't have to worry about staff changes, people, loss of information. If we need to spend more energy, my profession needs to spend more energy really making this kind of information available for professionals to exchange information. And we've done a terrible job of it, historically.